The concept of digital currency has been around longer than many people realize. While the idea of using digital means to represent value might seem like a modern innovation, its roots stretch back several decades. The early visionaries of the digital age foresaw a future where money could be transferred instantly and securely over the internet, bypassing traditional financial institutions. Early attempts at creating digital cash like DigiCash and eGold emerged in the late 20th century. These pioneering efforts aimed to create a form of money that could be used online, much like physical cash is used in the real world. DigiCash, founded by David Chaum in the late 1980s, was one of the first to introduce the concept of anonymous digital transactions. eGold, launched in 1996, allowed users to transfer gold ownership electronically, providing a digital alternative to traditional banking. These systems, however, faced challenges with security and centralized control, ultimately hindering their widespread adoption. Centralized servers became targets for hackers, and the reliance on a single point of control made them vulnerable to shutdowns and regulatory pressures. Despite their innovative approaches, these early digital currencies couldn't overcome the inherent risks associated with centralization. The true revolution in digital currency began with the birth of Bitcoin in 2008. Unlike its predecessors, Bitcoin introduced a decentralized approach to digital money, which fundamentally changed the landscape of financial transactions. This new system promised greater security, transparency, and independence from traditional financial institutions. Bitcoin was introduced to the world through a white paper authored by the pseudonymous Satoshi Nakamoto. This mysterious figure, or group of individuals, outlined a vision for a new kind of digital currency that would operate without a central authority. The white paper, titled Bitcoin, a peer-to-peer electronic cash system, detailed the technical foundations and philosophical underpinnings of this groundbreaking technology. The paper outlined a revolutionary system for peer-to-peer electronic cash. This meant that transactions could be made directly between users without the need for intermediaries. By leveraging a network of computers, Bitcoin transactions could be verified and recorded in a public ledger, ensuring transparency and security. This system would rely on a decentralized network, eliminating the need for intermediaries like banks. Each participant in the network, known as a node, would contribute to the validation and recording of transactions, creating a robust and resilient system. This decentralization was key to Bitcoin's security and its resistance to censorship and fraud. This marked a significant departure from traditional financial systems. In conventional banking, transactions are processed and verified by central authorities, such as banks and payment processors. Bitcoin's decentralized model challenged this paradigm, offering a new way to think about money and financial transactions. At its core, Bitcoin introduced the concept of a cryptocurrency secured by cryptography. This cryptographic security ensured that transactions were tamper-proof and that the creation of new Bitcoins followed a predictable and transparent process. The process of mining, which involves solving complex mathematical problems, was designed to maintain the integrity and scarcity of the currency. This meant that transactions were not only digital, but also tamper-proof and verifiable by anyone on the network. The blockchain, a public ledger of all transactions, provided a transparent and immutable record, making it nearly impossible to alter past transactions without the consensus of the network. This innovative approach addressed the issues of double spending and fraud that had plagued earlier digital cash attempts. Double spending, where the same digital token could be spent more than once, was a significant challenge for previous digital currencies. Bitcoin's blockchain technology effectively solved this problem by ensuring that each transaction was unique and irreversible. The introduction of Bitcoin marked a pivotal moment in financial history. It not only provided a new form of money but also sparked a broader movement towards decentralized finance. Over the years, Bitcoin has gained acceptance and recognition, influencing the development of numerous other cryptocurrencies and blockchain-based applications. It presented a viable alternative to traditional currencies and payment systems. As more people and businesses began to adopt Bitcoin, it demonstrated the potential for a decentralized financial system that operates independently of government control and traditional banking infrastructure. More importantly, it laid the foundation for the development of blockchain technology, the underlying technology powering Bitcoin and countless other cryptocurrencies that would follow. Blockchain's potential extends beyond digital currencies. offering new possibilities for secure, transparent, and decentralized applications in various industries, from finance to supply chain management and beyond. To understand cryptocurrency, one must first grasp the concept of blockchain technology. Blockchain is the underlying framework that enables the existence of cryptocurrencies like Bitcoin and Ethereum. Without blockchain, these digital currencies would not be able to function in the secure and transparent manner that they do. This groundbreaking technology serves as the backbone of most cryptocurrencies, ensuring their security and transparency. Blockchain technology is revolutionary because it provides a decentralized way to record and verify transactions, eliminating the need for a central authority or intermediary. A blockchain is essentially a distributed database that maintains a continuously growing list of records, called blocks. Each block contains a set of transactions that have been verified by the network. Once a block is completed, it is added to the chain in a linear chronological order. These blocks are linked together in a chronological order, with each block containing a cryptographic hash of the previous block. This hash function ensures that any alteration to a block would be immediately noticeable, as it would change the hash and break the chain. This creates a tamper-proof chain of records, making it virtually impossible to alter past transactions. The integrity of the blockchain is maintained through a consensus mechanism, where the majority of the network must agree on the validity of new blocks. This immutability is one of the key features that makes blockchain technology so secure. Once a transaction is recorded on the blockchain, it cannot be changed or deleted, providing a permanent and unalterable record. Furthermore, the distributed nature of blockchain means that the ledger is not stored in a single location. Instead, it is shared across a network of computers, known as nodes, each of which holds a copy of the entire blockchain. Instead, it is replicated across a network of computers, making it highly resistant to censorship and single points of failure. This decentralization ensures that even if some nodes go offline or are compromised, the blockchain remains operational and secure. This decentralized architecture is a significant departure from traditional centralized databases, offering enhanced security and resilience. In a centralized system, a single point of failure can bring down the entire network, but in a decentralized system, the network remains robust and resilient. The transparency of blockchain technology is another noteworthy aspect. Every transaction recorded on the blockchain is visible to all participants, ensuring that the system operates in an open and transparent manner. All transactions recorded on the blockchain are publicly viewable, promoting accountability and trust within the system. This transparency helps to prevent fraud and corruption, as all actions are visible and traceable. This transparency, however, does not compromise privacy, as users are identified by pseudonymous addresses rather than their real-world identities. This means that while the transactions are visible, the identities of the participants remain private, providing a balance between transparency and privacy. Bitcoin's security and functionality rely heavily on a process called mining. This process is fundamental to the operation of the Bitcoin network, ensuring that transactions are verified and added to the public ledger, known as the blockchain. This process involves specialized computers known as miners, competing to solve complex mathematical problems. These problems are cryptographic puzzles that require significant computational power to solve. The miners use their hardware to perform millions of calculations per second, all in the hope of being the first to find the solution. The first miner to solve the problem gets to add the next block to the blockchain and is rewarded with newly created bitcoins. This reward system is designed to incentivize miners to continue contributing their computational power to the network, ensuring its ongoing security and functionality. This process is computationally intensive and requires significant energy consumption. Mining farms, which are large facilities filled with mining rigs, consume vast amounts of electricity to power and cool the hardware. This has led to concerns about the environmental impact of Bitcoin mining. However, it serves as the backbone of Bitcoin's security model. The decentralized nature of mining ensures that no single entity can control the network, making it resistant to censorship and fraud. The difficulty of the mining process ensures that it is extremely costly for any single entity to gain control of the network. This difficulty is adjusted approximately every 2 weeks to ensure that blocks are added to the blockchain at a consistent rate, regardless of the number of miners participating. The rewards given to miners serve as an incentive for them to participate in the network and contribute their computing power. These rewards are halved approximately every 4 years in an event known as the halving, which helps control the supply of new bitcoins and mimics the scarcity of precious metals like gold. As more miners join the network, the difficulty of the mining process adjusts automatically to maintain a steady rate of block creation. This self-regulating mechanism ensures that the Bitcoin network remains stable and secure, even as the number of participants fluctuates. This ensures the stability and security of the Bitcoin network. The decentralized and competitive nature of mining makes it difficult for any single entity to manipulate the blockchain, providing a robust defense against attacks. The mining process is essential not only for creating new bitcoins, but also for verifying and confirming transactions on the network. Each transaction must be included in a block and added to the blockchain to be considered valid and irreversible. When a transaction is initiated, it is broadcast to the network of miners. These miners then compete to verify the transaction by solving the cryptographic puzzle associated with the next block. These miners then verify the transaction and include it in the next block they mine. This process ensures that all transactions are accurately recorded and prevents double spending, maintaining the integrity of the Bitcoin network. While Bitcoin pioneered the concept of cryptocurrency, Ethereum took blockchain technology a step further. Ethereum is not just a digital currency, it's a decentralized platform that enables the creation and execution of smart contracts and decentralized applications, or dApps. Smart contracts are self-executing contracts written in code and stored on the Ethereum blockchain. These contracts automatically enforce the agreed-upon terms between parties, eliminating the need for intermediaries. This opens up a world of possibilities for automating agreements and transactions in various industries. Decentralized applications, or dApps, are applications that run on the Ethereum network. Unlike traditional applications that rely on centralized servers, dApps are distributed across the network, making them more resistant to censorship and downtime. This decentralized nature empowers developers to create applications that are more secure, transparent, and accessible to a wider audience. Ethereum's native cryptocurrency, Ether or ETH, plays a crucial role in the ecosystem. It serves as the fuel that powers transactions and smart contract executions on the network. Users pay fees, known as gas fees, in ETH to compensate miners for their computational work in processing transactions and running dApps.